Hey, sixth graders, Mrs. Zimmerman here, and I am here with a brand new chapter. Can you believe it? Okay, so today's chapter, we're actually starting geometry. So we're going to be doing a lot of work with shapes, 3D shapes, finding area, surface area, volume, all kinds of things that you're going to learn. Okay, so the very first lesson is pretty simple. We are just going to be finding the area of a parallelogram. And then you're thinking to yourself, okay, great, what's a parallelogram? Well, I'm about to tell you. I'm gonna head up to the front and we'll get started. All right, so what we are doing, we are finding the area. And when we find the area of a shape, for example, I have here this green rectangle, okay? And if I wanted to find the area of this rectangle, I would be finding how much space does this shape take up. All of this here that I just shaded in, how much space is that? And we would find the area by multiplying the length times the width. Okay, so to find the area of a rectangle, you would just multiply length times width. So let's say this was 8 inches and that was 4 inches, right? If we wanted to find the area of this green rectangle, we would just do 8 times 4, okay? But we are actually learning something different. I just wanted to show you where we get that formula from, right there, length times width, okay? So what we have here is a rectangle, but the shape that we are going to be dealing with in this lesson is a parallelogram. Let me just make sure I spell it right. Parallelogram. There we go. Okay. And what is a parallelogram? Well, it's actually a rectangle that's broken into 2 pieces and just rearranged. If you look at the base word of parallelogram, it's the word parallel, right? So we've got parallel lines, lines that are never ever going to touch. And there's another set of parallel lines running this direction. And that's a parallelogram. All you do is just take a rectangle, oops, pretend those are back together, right? Just take a rectangle and move one of the sides over, cut it in half and move it over. So if you think about this, if I wanted to find the area of a parallelogram, I'm basically going to do the exact same thing I would do to find the area of a rectangle, because it's covering up the same amount of space, right? I'm either covering up this much space or I just rearrange it and I'm covering up this much space. It's the same amount of space, just in a different way. So the formula we're going to use for area of a parallelogram is base times height. It's very similar to length times width, but the words, the vocabulary that we're going to use is this right here, base times height. Okay, so let me tell you, show you what we're looking at. Okay, area of a parallelogram. Now, this here is just a very generic parallelogram. When we're talking about the base, we are talking about this length right here. Now, base doesn't always have to be on the bottom, okay? Sometimes your base might be over like here, off to the side. That's okay, that is still a base. Okay, so B stands for base. Now, the height is this distance right here. Okay, now notice how it's not this. This is not the height. Okay, that's just the slant. That's not how tall it really is, right? How tall it really is going to be this distance right here. And even if it's flipped on its side, like my little drawing over here, that would be the height. So the height doesn't always have to be vertical and the base doesn't always have to be horizontal. they can go either direction, but we're still going to use area equals base times height. Okay, and when we use area, we always write it with a capital A. So let's do some examples. Okay, so I have area equals base times height. We've already decided this, right? So I'm going to look at my parallelogram and see, where is the base? Well, remember the base, it doesn't have to be the horizontal line. In this case, it is. It's 12. So where the B is, I'm going to do area equals 12 meters, because my measurement is in meters, times my height, which is, again, this distance, 14 meters. Okay? And then this is just an equation, right? We're trying to figure out what A equals. So we just do 12 times 14. And if you've got a calculator, you can just put that in. And area equals 168. Now, when we do area, every number has to have a label. So think about this, okay? We have 12 times 14, and that's 168. But I'm also multiplying, it's not just 12, it's 12 meters times 14 meters. So 12 times 14 is 168. What's meters times meters? Well, meters times meters is meters squared, right? Think of any number. 8 times 8 would be 8 squared. So that's my label. This whole thing would be the answer, okay? And so when I'm working on grading your homework and you're putting things into big ideas, you have to have the label and you have to have this squared, okay? Because if you don't, then we're not talking about area. But let's do another one, okay? So I've got another parallelogram, and my formula, remember, is area equals base times height, okay? So let's plug in the numbers. My base here, you can see, is 4 feet. So we're going to do 4 feet times my height, which they have put over here to the side. And that's okay, right? Because it's the same distance as that. They just put it outside instead. And 8.5 feet is my height, and I know that 8.5 can be written like 8.5. And then all you have to do is just do your calculating. So 4 times 8.5 is 34. And then feet times feet is feet squared. And that would be your answer. Okay, hopefully you're kind of getting the hang of this. Let's do one more. Oops, right here. Yeah, here we go. Okay, so again, remember, area equals base times height. Okay, this parallelogram here, my base is 20. So I'm going to do area equals 20 meters times my height, which is 25 meters. All right, you should be getting the hang of this by now, right? We're just going to do 20 times 25, which is 500. And meters times meters is meters squared. All right, now hopefully that's making a little bit of sense to you, and I'm actually coming back to show you something that we're going to need for the next type of problem. So what I want to show you next is this piece of paper right here, these conversion factors. Do you remember this worksheet? It should be in your math fact folder. If you don't have that, I'm actually going to post a copy of this on Google Classroom, okay? And I want you to use this sheet, because if you just Google some of these conversions, you know, Google sometimes rounds a little bit differently than I do, or they go out an extra number, or they do things kind of differently. And in order for you to get the right answers, at least the ones you know, they would all be considered correct, but the way that Big Ideas is going to count it is using these conversions right here. Okay, so if you don't have this worksheet handy, I'm going to post the thing at the top of Google Classroom. That way it'll just, I'll call it conversion factors, and then you'll just be able to use it. Okay, and these are going to come in handy for our next type of problem, because what we're going to be doing next is converting the measurements. Okay, so let's head up to the front and look at this problem. We have directions here that say to find the area of the parallelogram in square inches. Okay, that's great, you say, but look at the problem. What measurements do we have? We have feet, 2 feet and 2.5 feet. What am I going to do, right? My measurements are in feet, and they want me to have my answer in square inches. So whatever I do, my area has to equal inches squared. So how are we going to get there? Well, the very first thing you need to do is convert these measurements before you even do the formula. Okay, so right, our formula is area equals base times height, right? But why would we multiply feet when we want our final answer to be inches? So what we're going to do is we're going to take 2 feet, and we want to change that into inches. If you remember this, we did this back in chapter 3. Here's how you convert measurements, right? If I have 2 feet, I just multiply that by whatever my conversion is. So I go to my little sheet, and it says, I'm looking for the one that has feet and inches in it. Okay, which conversion? I have 1 foot equals 12 inches. Okay, now what? Well, I cross simplify. My feet are going to cancel, so my final answer is going to be inches. And what's 2 times 12? I know that's 24. So what did I just do? This is no longer 2 feet. This is 24 inches. Now I have to do the next one. I have 2.5 feet times, grab my conversion chart. We're trying to go to inches here. Okay, then I just put feet on the bottom. So what is that relationship? We already found out 1 foot is 12 inches. My feet are going to cancel, so my answer will be inches. And what is 2.5 times 12? Well, if you know that, great. Otherwise, you can put it in your calculator. The answer is 30. So no longer is this 2.5 feet. It is 30 inches. There. Now this will be so much easier, right? Because my formula, remember, is area equals base times height. And we need to get our final answer down here. Oops, I kind of made that really thick. My bad. We need to get our answer into inches. So I have 24 inches times 30 inches. 24 times 30 is 720. Inches times inches is inches squared. So now I know my problem is finished. Oh, cool, right? That's not bad. Let's do another one. All right. We want to find the area of the parallelogram in square meters. Okay, so we're not using inches and feet. We are now moving to meters and centimeters. My final answer, centimeters. So I'm going to put that down here just so I know exactly what I'm trying to do here. Okay, the first thing you're going to want to do is convert your measurements. My base is 4 meters. My height is 10 meters. Okay, let's change those into centimeters. We start with 4 meters, and we're going to multiply by the conversion. I'm starting with meters. I want to end up as centimeters. So let's go to our chart. Meters and centimeters, what does it say? 1 meter equals 100 centimeters, right? Yeah, okay. Meters cancel. My final answer is centimeters. What is 4 times 100? That's easy. 400. Okay, so no longer 4 meters, but 400 centimeters. Now we have to do the same thing with 10. 10 meters times centimeters over meters. All right, we know the conversion is 1 to 100. And then we just cancel out the meters. And our answer is 10 times 100. That is 1,000 centimeters. So I'm going to cross this off. Now I have 1,000 centimeters. Okay, am I finished? No, right? My goal here is to get the area. So my formula, area equals base times height. My base is 400 centimeters times my height, which is 1,000 centimeters. Oops, don't put squared yet. Jeez. Okay, then we just multiply those two together, right? 400 times 1,000 should be 400,000. Let's see if I can fit that in. 400, there we go, 1,000 centimeters squared. Whew, that's a big number. There we go. Okay, maybe let's try one more like this, just to be sure. All right. Find the area of the parallelogram in square feet. Feet. Okay, so my answer is going to have to be something feet squared. I've got 4 yards and 3.5 yards. Okay, so we're going to start with 4 yards. We're going to times that by a fraction. We're starting with yards. We want to end up as feet. So I go to my conversion chart. Yards to feet. In 1 yard, there is 3 feet. All right, yards are going to cancel. What's 4 times 3? 12 feet in 4 yards. Okay, so no longer is this 4 yards, but 12 feet. And then we're going to do the same thing for 3.5. Hopefully we're getting the hang of this by now, right? We're going to times it by a fraction. Start with yards, end as feet. So we have 3 over 1. My yards are going to cancel, and I'm going to take 3.5 times 3 and get 10.5 feet. All right. Now, let's switch colors so we can see it. We're going to do area equals base times height. My base, I know, is 12 feet times my height, which is 10.5 feet. Okay, grab your calculator, throw it in, and you're going to get 126. Feet times feet is feet squared. Ooh, there we go. Okay, that was 3 good examples. Hopefully, this is making a little bit more sense to you. The biggest thing to remember is to convert the numbers before you find the area. And if as long as you do that, you will be just fine. Now, the next type of problem, we will be, what do the directions say? Find a missing dimension. Ooh, find the missing dimension of the parallelogram described. Okay, if the base is 6 feet and the area is 54 feet squared, what is the height? Well, let's see. The first thing I think I'm going to do is to draw a picture, okay? So here's my parallelogram. My lines aren't quite perfect, but we'll get the idea, right? They're telling me that the base is 6 feet. So we have 6 feet down here at the bottom, and the area is 54 feet squared. So what is the height? That means we're trying to figure out that distance right there. And we know that that is h. So how could we figure this out? Really, this is just an equation, right? With a variable, just like we did in the last chapter. Because if you think about our formula, area equals base times height. Well, let's just plug in the numbers. My area is 54. My base is 6. Do I know what my height is? No, so we just keep it like that, right? And we know how to solve this equation. We use inverse operations. Because 6 times h, well, we want to get h all by itself. So what's the opposite of multiply? Divide. So we're going to divide by 6 on both sides. These cancel. I'm left with h equals, what's 54 divided by 6? 9. And my label here is feet. So what does h equal? 9 feet. Easy as that. All right? Here's another one. If the height is 2.5 centimeters and the area is 16 meters, what is the base? Okay, now I could draw myself a picture, but we just figured out, right? This is an equation. Area equals base times height. So let's just put the numbers in. What does A equal? 16. What does B equal? We don't know. Oops, my bad. We don't know what B equals, so we're going to keep it B times H, which is 2.5. And now we can solve, right? The inverse of multiply is to divide. So we're going to divide by 2.5 over here and over here. These cancel. So I have B equals 16 divided by 2.5 is 6.4. What measurement here? Centimeters. And now notice I'm not putting centimeters squared because I did not find the area, right? The area is already squared over here. But the base is just a regular height, so or measurement, I should say, so we're just going to use centimeters. Let me see what else we got. All right, last one. A billboard is in the shape of a parallelogram. The billboard has a base of 48 feet and a height of 14 feet. So find the area of the billboard. All right, you know I'm going to draw a picture. Okay, so a billboard, right? Think of you're driving down the road, and there's those signs on the side of the road. They're big, they're huge. They've usually got come eat at Perkins or make sure you shop at Target, something like that, right? There's my billboard off the side of the road. And they're telling us that the base is 48 feet. So I know that the base is going to be 48. And the height is 14. And I know this distance right here is 14. So my formula is area equals base times height. We want to find the area. The base is 48, and my height is 14. Okay, these measurements are in feet, so my final answer will need to be feet squared. Okay, we're just going to do 48 times 14, 672 feet squared. That is the area of my billboard. So story problems are going to be just the same, and that's our whole lesson. That's it. Okay, we did 3 things. We found the area of a parallelogram, we found the area of a parallelogram converting units, and we were able to find a missing dimension. So those are your 3 tasks for this lesson, and good luck.